Hi, let us check different properties of Lebesgue outer measure. In the previous video, we had defined what is a Lebesgue measurable set. E is said to be Lebesgue measurable if for any set A, m star of A is equal to m star of A intersection E plus m star of A intersection E complement. And in the previous video, we have seen that some properties of Lebesgue outer measure is Lebesgue measurable if and only if its complement is Lebesgue measurable. Also phi and r are both are Lebesgue measurable set, and any set of outer measure 0 is Lebesgue measurable. That means any countable set is Lebesgue measurable. And also if E1 and E2 are two Lebesgue measurable set, then its union E1 union E2 Lebesgue measurable, and intersection E1 intersection E2 is also Lebesgue measurable. Okay, ഇത്രയുമാണ് നമ്മൾ കഴിഞ്ഞ സെക്ഷനിൽ കണ്ട പ്രോപ്പർട്ടീസ്. ഓക്കെ, അപ്പോൾ നമ്മൾ പറഞ്ഞ സെറ്റ് ഓഫ് Lebesgue മെഷറബിൾ സെറ്റ് എന്ന് പറയുന്ന ആ Lebesgue മെഷറബിൾ സെറ്റ് എന്ന് പറയുന്ന ആ ഒരു കളക്ഷനിൽ ഇപ്പം നമ്മൾ എന്തൊക്കെയുണ്ടെന്ന് കണ്ടു. ഈ Lebesgue മെഷറബിൾ സെറ്റ്സ് എന്ന് പറയുന്ന കളക്ഷനിൽ വരുന്നു. ആർ Lebesgue മെഷറബിൾ കളക്ഷനിൽ വരുന്നുണ്ട്. എനി കൗണ്ടബിൾ സെറ്റ്സ് ഇറ്റ് ഈസ് ഓൾസോ ഇൻ ദിസ് കളക്ഷൻ. ആൻഡ് ഓൾസോ എനി സെറ്റ് വിത്ത് ഔട്ടർ മെഷർ 0 m star 0 ഈക്വൽ ടു 0 ആകുന്ന സെറ്റുകൾ ഇതിൽ വരുന്നു. പിന്നെ ഒരു സെറ്റ് ഇതിനകത്ത് വരുന്നുണ്ടെങ്കിൽ അതിൻ്റെ കോംപ്ലിമെൻറ്റും ഇതിനകത്ത് തന്നെയാണ് Lebesgue മെഷറബിളാണ്. പിന്നെ രണ്ട് സെറ്റുകൾ മെഷറബിളായിട്ടുള്ള രണ്ട് സെറ്റുകൾ എടുത്തു കഴിഞ്ഞാൽ അതിൻ്റെ യൂണിയനും ഇൻ്റർസെക്ഷനും Lebesgue മെഷറബിളാണ്. അപ്പോൾ ഈ സെറ്റ് എന്ന് പറയുന്നത് ഒരു ചെറിയ സെറ്റല്ല, ഒരുപാട് എലമെൻറ്റുകളെ കണ്ടെയ്ൻ ചെയ്യുന്ന ഒരു ബിഗ് സെറ്റ് തന്നെയാണ്. നെക്സ്റ്റ് പ്രോപ്പർട്ടി ഡിസ്കസ് നോക്കാം. If m star of E is equal to 0, then every subset of E is measurable. Okay. If E is a set with the outer measure 0, then its subsets are also Lebesgue measurable. Okay, consider E with the m star equal to 0. M star of E 0 means it is measurable, and consider a subset F of E. Then by monotonicity m star of F is less than or equal to m star of E. But our m star of E is 0, so this become m star of F less than or equal to 0. But the converse, that means m star of F is greater than or equal to 0 always. From these two we have equal to 0. That means m star of F is 0. Any subset of a set of with outer measure 0 is having its outer measure 0. Okay, that means it is outer measure 0 means the set is measurable, that is F is measurable. Now an important theorem in this section: the union of a finite collection of measurable set is measurable. Okay, suppose we have a finite collection of measurable set, then its union is again a measurable set. Okay, previously we have seen that if we have two measurable sets, then its union E1 union E2 is measurable. We have seen in the previous video. Okay, now we are generalizing that idea into a finite number of collection of measurable set. Okay, we use induction to prove the idea. Consider sequence k equal to 1 to n be a finite collection of measurable set. Then when n is equal to 2, n 2 നമ്മളിത് പ്രൂവ് ചെയ്യുന്നു. Then for n equal to k minus 1 assume ചെയ്ത് n equal to k നമ്മളിത് പ്രൂവ് ചെയ്യും. Okay, so when n equal to 2 means we have two measurable set E1 and E2. We have to prove E1 union E2 is measurable. Okay, E1 and E2 two measurable set. We have to prove that E1 union E2 is measurable. That we have already seen in the previous theorem. So ഞാനതവിടെ റിപ്പീറ്റ് ചെയ്യുന്നില്ല. ദ സെയിം തിയറം we can say that E1 union E2 is measurable. Now by the method of induction we assume that the result is true for k minus 1 case. K minus 1 collection of k minus 1 finite collection of measurable set. That means if we have k minus 1 measurable set, E1 E2 etc. Ek minus 1, then its union, the induction says that this union n equal to 1 to k minus 1 En is measurable. Now what remaining is that is the case for n equal to k. That is n equal to trueന് നമ്മൾ പ്രൂവ് ചെയ്ത് കാണിച്ചു. n equal to k minus 1 നമ്മൾ assume ചെയ്തു. Next we have to prove it for n equal to k. So consider the k elements of measurable set. That is we have E1, E2 etc. up to Ek measurable set. Consider its union over n equal to 1 to k En is equal to, we can split it as union of over n equal to 1 to k minus 1 En union the last member Ek. Here we have k elements. Here we split it as union of k minus 1 and the kth member Ek. Okay. Then already in the case when n equal to 2, we have seen that for any two measurable set, its union is measurable. Okay. രണ്ട് മെഷറബിൾ സെറ്റുകൾ ഉണ്ടെങ്കിൽ ഇറ്റ്സ് യൂണിയൻ ഈസ് ഓൾസോ മെഷറബിൾ. ഹിയർ ഓൾസോ വി ക്യാൻ പ്രൂവ് ദാറ്റ്, ഹിയർ വി ക്യാൻ യൂസ് ദാറ്റ് ഐഡിയ ടു പ്രൂവ് ദിസ്. ഓക്കെ, ദാറ്റ് ഈസ് ദാറ്റ് previously we proved that this term up to k minus 1 En, this term is measurable, and also by assumption Ek is also measurable. That means we have two measurable sets. Then its union is also measurable by the first part. Therefore, union over n equal to 1 to k En is measurable. That is, we can say that by mathematical induction, this is true for any natural number n. Finite union of measurable set is measurable. Then next one is another proposition. Let A be any set, sequence Ek, k equal to 1 to n is a finite disjoint collection of measurable set. Finite disjoint collection of measurable set. അപ്പോൾ ഈ പ്രൊപ്പോസിഷനിലെ ഈ കേസ് ഒന്ന് ശ്രദ്ധിക്കുക. They are finite collection, also ഈ കേസ് are disjoint. They are measurable also. Then m star of A intersection union Ek is equal to summation m star of A intersection Ek. Okay, in particular m star of union Ek, union over k equal to 1 to n equal to summation m star of Ek. Okay, it means if we have a finite disjoint collection of measurable set, finite ആണ്, disjoint ആണ്, measurable ആണ്, then m star of A intersection union Ek is equal to, we can write it as summation. Okay, summation of m star of A intersection Ek. We use the method of induction. First case, when n equal to k equal to 1. Here 1 means the left hand side LHS is this collection contains only a single set E1. That is, the left side become m star of A intersection E1 only, A intersection E1. Then now what about the RHS? It contains only the first term, that is m star of A intersection E1. That means LHS RHS are same. That is, the result is trivial. Now assume that the result is true for n minus 1 terms, n minus 1. That is, m star of A intersection union over k equal to 1 to n minus 1 Ek equal to summation 1 to n minus 1 m star of A intersection Ek. Now we have to prove it for n. So consider finite disjoint collection of measurable set E1, E2 etc. Ek, E1, E2 etc. Ek. Okay. Then find out m star of A intersection union k equal to 1 to n ek. That is equal to, here we use the definition of measurability of En. Last term En is measurable, use the measurability of En. Then this is our general set A. Okay, just to consider it as a set A. Then by definition it is m star of A intersection, ഇത് എ എന്ന് പറയുന്ന സെറ്റാണെങ്കിൽ എ ഇൻ്റർസെക്ഷൻ ഇ എൻ പ്ലസ് എം സ്റ്റാർ ഓഫ് എ ഇൻ്റർസെക്ഷൻ ഇ എൻ കോംപ്ലിമെൻറ്റ്. ഹിയർ അവർ എ ഈസ് ദിസ് മച്ച്, എ ഇൻ്റർസെക്ഷൻ യൂണിയൻ ഇ കെ. സോ m star of A intersection union Ek intersection En. Here we consider the definition of measurability of En. En measurable ആണെന്നാണ് യൂസ് ചെയ്യുന്നത്. Then next term En complement. Okay, A intersection union Ek intersection En plus m star of A intersection union Ek intersection En complement. Okay, then what about the first term on RHS? Consider the first term. Here union k equal to 1 to n ek intersection ek. What is the value intersection? Here this union contain E1 union E2 union etc up to En. Then intersection with the En. We have a property that sequence, it is given that sequence EKs are disjoint also. Okay, so ഇവിടെ നമ്മൾ എടുക്കുന്നത് യൂണിയൻ ഓഫ് ഇ കെ 1 മുതൽ n വരെയുള്ള എല്ലാ എലമെൻറ്റുകളും വന്നിട്ടുണ്ട്, അതെല്ലാം ഡിസ്ജോയിൻ്റ് ആണ്. ദെൻ ഇ എന്നുമായിട്ട് നമ്മളിവിടെ ഇൻ്റർസെക്ഷൻ എടുക്കുന്നു എന്ന് പറഞ്ഞാൽ ഇതിൻ്റെ കോമൺ ഫാക്ടർ എന്തായിട്ട് മാറി? ഇ എൻ. ദാറ്റ് ഈസ് വി ക്യാൻ റീറൈറ്റ് ദ ഫസ്റ്റ് ടേം ആസ് എ ഇൻ്റർസെക്ഷൻ ഇ എൻ. ദെൻ വാട്ട് അബൌട്ട് ദ സെക്കൻഡ് ടേം? യൂണിയൻ k equal to 1 to n ek intersection En complement. Okay, union ek intersection En complement. Here we consider En complement. En complement means that contains E1 element, E2 element, E3 element etc. So the union of ek intersection En complement is A intersection union k equal to 1 to n minus 1 ek. Okay, അപ്പോൾ പറഞ്ഞത് യൂണിയൻ ഓഫ് ഇ കേസ് എടുത്തു 1 to n, ഇൻ്റർസെക്ഷൻ ഇ എൻ കോംപ്ലിമെൻ്റ് എടുത്തു. ഇ എൻ കോംപ്ലിമെൻ്റ് എന്ന് പറഞ്ഞാൽ ഇ എൻ ഇല്ലാതെ എല്ലാ എലമെൻറ്റുകളും അവിടെ വരുന്നത്, അതായത് E1 E2 E1 യൂണിയൻ E2 യൂണിയൻ എക്സെട്ര അപ് ടു En മൈനസ് 1 വരെ. അപ്പോൾ ഈ രണ്ട് സെറ്റുകൾ തമ്മിലുള്ള ഇൻ്റർസെക്ഷൻ ഇവിടെ 1 to En ആണ്, E1 E2 എക്സെട്ര En. Here E1 intersection E2 intersection etc up to En minus 1. Therefore this intersection gives E1 E2 etc En minus 1. Okay, then by the previous proposition m star of A intersection union Ek is same as summation of m star of A intersection Ek. Just add this value. Here the summation is over k equal to 1 to n minus 1. Add this term also, that is m star of A intersection Ek where k equal to 1 to. Then to prove the particular case, just substitute A as R. Then the result become m star of union Ek equal to summation m star of Ek. Next notion is algebra. I think you are familiar with this notion, algebra. Algebra means a non-empty collection of subsets that satisfies some properties. First one is phi must be a member of that collection. Secondly, it is closed under complement. That means if m is in that collection script A, then its complement m complement also belongs to A. Then thirdly, A is closed under finite union. That means if we have 2 or 3 sets, then its union is also belongs to A, is also in A. And this ഇത് നിങ്ങൾക്ക് വേണമെങ്കിൽ ഒന്ന് മോഡിഫൈ ചെയ്ത് എഴുതാം. A1, A2, etc. AN belongs to script A. That means these things are measurable. Then its union is also belongs to A. Measurable at belongs to A. Okay, this is the definition for algebra. That means algebra means a non-empty subset of S, a non-empty subset that satisfies these 3 things. First one is phi belongs to that collection, and A is closed under complement, and it is also closed under finite union. And remember that it is a finite union. A is closed under finite union. That means if you have a finite collection of elements A1, A2, A3, etc. AN, then its union A1 union, A2 union, etc. union AN belongs to this collection. Okay. Then if A is an algebra, by the third property it is closed under finite union. Then from that property we can see that A is closed under finite intersection also. Okay, that is algebra. From the definition, it is closed under finite union, and by using De Morgan's law we can prove that algebra is closed under finite intersection also. So consider 2 sets A and B from A, then its complement A complement and B complement, those also belongs to script A. Hence the union belongs to script A because A is an algebra. That means if A is here, then A complement is here, and B is here, then B complement is here. Therefore its union also belongs to script A. Then by De Morgan's law we can rewrite that A intersection B whole complement belongs to script A. That means A intersection B complement, as set belongs to A, then its complement also belongs to A. That complement is A intersection B. That means if we have an algebra which is closed under finite union by the definition, and here we proved that it is closed under finite intersection also. Okay, thank you.